There we have. Now we have sound. Some have told me it's a better show with sound. I'm not sure I believe them. All right. We'll give people a little bit of time. Let's see. I'm just going to update the title a little bit. All right. Let me make sure that. Nice. All right. All right. Seems all updated. All right. Well, yeah, we'll get started. We had a bit of things happen this week. Kind of interesting. We have a couple things here in security. Some things that are kind of a little outside the difference in security. But a couple things that I really think are going that could affect you guys that are in pretty much everything. Every major system has some Apache Apache things, and how much money Oracle makes. Same with Oracle. Um, so yeah, we're gonna talk about some of those because they might affect you. So again, for any of you that might join me for my programming streams, this is not the programming streams, just going over for the news for the week. So let's see how it goes. After that, we have some cloud news. There's actually a couple, at least one person that I don't chronically talk about, but they definitely released some stuff that we're going to cover and talk about. Then we have some stuff on Kubernetes and open source that I saw. And then we have a pretty big article to review, so I'm going to try to go quickly so that we have plenty of time to cover that article. All right, let's start with our security like usual. Researchers discovered vulnerabilities in the Azure API management service. Now, this also seems that these have been resolved, but yeah, they were found as well. So it's an interesting read just to understand exactly what was happening there and how they were vulnerabilities. But at the same time, if you are using Azure, I don't believe that there's anything that you need to do at the moment. Microsoft is usually pretty good about letting you know if there's something on your side that you need to do. But this I found interesting. Microsoft is busy rewriting Windows code in memory safe Rust. The reason this is in the security section here is because this was actually at the Blue Hat in Tel Aviv, where the director of OS security for Windows announced the arrival in the kernel, and basically they're moving some of these critical things that have vulnerabilities in the Windows kernel to run with Rust. So I thought this was worthy of going in the the security thing. We've talked a lot about Rust, its community, its viability, and whatnot. And so yeah, I put it in security, but it's also it's about security. It's not about open source at all. So yeah. Anyways, Windows will if you're running Windows, you're about to be running some Rust every single day. That's really cool. We also know that it's entered into the Linux kernel Lite as well. So it's showing up everywhere. It's showing up everywhere. Maybe bigger on the data breaches here was the ChatGPT OpenAI data leak, which interestingly enough actually affected Samsung. So Samsung employees were actually uploading internal code for ChatGPT review, and actually leaked. Uh, actually was leaking Samsung code. So, you know, yeah, this is why understanding the blast radius of some of these things is important. But yeah, so this is also why I consider security so important. Even if you're just an engineer, people are trusting you with their data, whatever that data happens to be. And I think it's important for us to do our best to protect it. Obviously, even I am of the opinion that stuff is going to happen. You're never perfect. But that's why it's important to take it seriously. On that, there is active exploit of TP-Link, Apache, and Oracle vulnerabilities. These are the CVEs down here. I'm going to throw this in because these are the ones I think could actually be affecting you all. So check those out. This is the Apache Log4j2. That hurts. That hurts for Log4j. Deserialization of untrusted data vulnerability. There's WebLogic server from Oracle and the TP-Link Archer. So all of these are pretty bad, as well as avoidable, as well as actively being targeted and used. So what they mean by active exploitation is they're actually monitoring people that are actively exploiting these things. So it's not like there's a theoretical vulnerability. There's actually people leveraging them. So if you're using any of these, check these out and make sure that you have a patched version, or sometimes you're using the library but you're not actually using the insecure portion of it. So you have to do like a real stringent review and isolate it somehow. But yeah. Again, in this is insecurity, and I know we're talking a little bit more about Rust insecurity than I normally like to, but an AWS-backed group believes, sudo and su are getting a little old, and so they're rewriting them. And I actually found the repos. This is cool. They're open source. They're not nearly ready to use, so don't go be using them. But this is actually pretty cool because they're saying these are core security mechanisms in Linux that need to be written in a more modern, more better way, and in a more secure language than C. So I do think that eventually some things just need rewritten. I think a lot of the times it's bad. If it's working, don't touch it. It's working. But there have been vulnerabilities in sudo in those things that have been there for 14, 17 years and nobody ever caught them until recently. I forget which one it was. It was in sudo last year. There was a bug in sudo. Again, this is where this is really cool. I'm excited to see this type of stuff. All right. That is it for security. Now we're going to move on to clouds. Now I said that there was a new cloud here that we're going to talk about that I don't think we've ever actually talked about. I'm going to leave that for last, and then we're going to get into some open source news, and then we're going to get into some AI, machine learning news, and yeah. So, did you guys have anything for security? Do you have anything for that? Or do you have anything for the cloud news that you'd like to make sure is covered? Well, let's jump into our cloud news. I'm going to start this off with a link for you all. So this link here is Google had their whole I/O thing that didn't actually come out as a clickable link. You'll have to copy it. Google did their whole I/O, and they have some release stuff. I haven't gotten to watch all of the videos or anything, so I can't talk to you about exactly once things on here, but we do have a few things in the Google Cloud to go ahead and cover. So microservice observability is generally available now for the C++, Go, and Java languages. This is pretty cool. Unfortunately, they don't have one for Rust, but this basically allows you to really easily tie your microservice observability into the GCP suite of observability tools. So yeah, this is their overview, and it basically ties everything, all of your microservices and stuff into their cloud monitoring and logging and tracing frameworks on with gRPC calls. So it makes monitoring and observability really a lot easier if you're on GCP. This was something I found very interesting, is they're extending zero trust access to multi-cloud applications. So I'm pretty big in zero trust, and this was pretty, I'm pretty excited to see, work being done to give you a single zero trust access plane control. I don't know how to explain that, but anyways, we are committed to supporting our customers who want our applications hosted outside of Google Cloud. In 2022, we named the overall leader. Okay, whatever. Overall leader. Yeah. So basically what they're doing is they have this thing called Beyond Corp, and Beyond Corp is their kind of thing that allows you to run zero trust. And they're helping bring that to your data centers as well. So this is really cool, especially if you're looking at either multi-cloud or your own data center, which just is extended by the cloud. This is very nice. Very nice. All right. Introducing active assistance recommendations for service limits. So service limits, or more commonly known as quotas in AWS, is notoriously a pain point for a lot of people. I can't tell you how many times people struggle with like quotas and service limits in all of the clouds. I don't know about Azure, but I'm guessing in Azure as well. And basically a quota or service limit is just a way to keep you from, they want to make sure that you pay your bill. So when you first log in as a new account, you can't spin up a million nodes of something. They're not going to let you do that, and you have to kind of slowly build that up so that they, it kind of forms some trust. So they have a new active assistance that helps you track and act on. This is a huge thing. This right here is awesome, because a lot of the times these service quotas just end up biting people in the butt when they all of a sudden, something that normally scales just stops scaling, or they try to make a new deployment and it just doesn't work. And a lot of times the error is esoteric. It's kind of inside of the cloud provider, and even then, sometimes it can break your service, and you didn't even know you were close to one of your quotas. So having a new active assistance that helps you track and act on quota limits is awesome, because it's going to sit there and analyze your quota utilization and actually provide you with actionable and automatic recommendations to kind of help you stay out of this place where you accidentally shoot yourself in the foot because you didn't know you were about to bump into one of those. And the hard part is there are hundreds of, maybe even thousands of different quotas in each cloud provider. So keeping track of them is just beyond difficult. And a lot of them are per region. So if you have hundreds of quotas per region, it just can become a nightmare to keep track of. So this is awesome. A lot of people just bump up their quotas as far as they can. That's kind of the thing. I think everybody should do this. If you have a quota, you should have an intelligent way to be reminding them, to let them know when they're at 80%. That wouldn't be too hard. This is awesome. Sorry, I don't mean to. I think this is really cool. All right. They also have introducing organization restrictions, a new way to keep track of to keep threat actors out. So this is just providing more fine-grained control in your IAM policies and access controls to try to help, give least access and make sure that if somebody's credentials do get compromised, they have least access. There's the smallest possible blast radius, and whatnot. A lot of the times, least access is hard because you don't necessarily know everything that a person needs to get to, especially for small teams. That's not well known. And so a lot of times people just give way too much access for things that they don't really need. And so this is helping people do that quickly and easily, and understanding organization structure and restrictions, and keeping people at bay. So that was all I saw at GCP. Although I do know they had quite a bit at their IO conference. So I'm thinking I'll be seeing some more stuff throughout the week. If you guys saw something that you thought was really cool, leave a link. Drop a link. All right. AWS. Amazon Aurora Serverless V2 is now available in 4 additional regions. You know that they didn't have a whole lot to go over if I'm talking about Serverless V2 being available in more regions. But I thought it was worth going over if some of you are using Amazon Aurora Serverless. There are 4 new regions that you can go to. So you have the Asian Pacific, the European, Spain, Zurich, and the Middle East. Data centers now support this. So if that was you, then this is fantastic. AWS really didn't have a whole lot. This is probably the one of the bigger things is Amazon MKS adds support for Kafka version 3.4. So this was what version did I don't remember what version. I'm guessing it was 3.3 something, but they just updated to 3.4. So you can now, if you're on MKS or MSK, I don't know why I say MKS, MSK, you're now able to upgrade to version 4.3. So that being said, I know in 4.3 or 3.4, in 3.4, I do believe you can actually do Apache without Zookeeper, but interesting note, Amazon will continue to use and manage Zookeeper for quorum management in this release. So their management system, they've already managed Zookeeper. They're already doing that for you. And so it seems like they're saying there's no reason to stop, doing it how they've been doing it because it's working. So they're not moving to the Zookeeper-less, which I think is probably the biggest thing in Kafka news is when they went Zookeeper-less for quorum. A huge benefit not to have Zookeeper there. Something for you EKS lovers out there, Amazon EMR on EKS launches vertical auto-scaling to auto-tune application resources. Now, what does that exactly mean? Well, it means that vertical auto-scaling, the ability to scale the vertical, the size of the base thing there on EKS is now there. So you can actually auto vertical scale now as well. So yeah, this enables customers to run open source big data frameworks such as Apache Spark or Amazon EKS on Amazon EKS without having to manage application provisioning themselves. It allows you to configure the amount of memory and CPU's cores that it will utilize. However, tuning these values until now have been very manual processes for customers and can be complex. So yeah. We read a blog or a couple blogs on this actually about limiting memory and CPU and whether you should do it or shouldn't do it. And there's seemingly a few schools of thought on this, but too little can result in out of memory exceptions, but allocating too much can result in overspending on this. And so basically, this is trying to get it just right for you automatically. Sounds pretty nice. On Azure, generally available Azure Event Hub, dedicated self-serve scalable clusters for mission critical Kafka, AMQP, and HTTP. I only know Kafka. I mean, I know HTTPS, but that's not really the same thing as Kafka. So, anyways, the self-serve clusters are built for are purpose built for mission critical event streaming. So basically, their event streaming is generally available for event hubs with dedicated self-serve clusters. So if that's something you were looking forward to or something you need, awesome. Azure cold storage. So I know that a lot of companies are looking to save money. Something that you can do is take your hot storage and move it to cold storage, and you can save a lot of money that way. Azure is releasing more cold storage out there. Who knows? Maybe it's in the Arctic. Not actually, but that's in taped and then shipped, and that's a different thing. Anyways, but basically, yeah, cold tier pricing is positioned between cool and archive. So they have a bunch of tiers, and each one of them have like how much it costs to access. So like some of the cold storage, it actually costs to access the data, and it almost costs barely anything to store the data and things like that. So it's worth looking into and understanding, how likely you are to touch the data and how much you could save by using it or leveraging it. Azure Backup Service v4. I don't know much about backup service, but the version 4, the best version yet today, that's what I've been hearing about it, is out there now for you guys. So go ahead and use it. You have access to the best Azure Backup Server since v3, pretty much. I don't know. People probably hate the backup server. I don't know. I don't know what it does. It looked like if you were on Azure, it would be useful. I mean, I obviously know what it does, unless it's named worse than anything. But I know it backs up. I think it backs up. I'm not sure if it backs up their servers, but I know that it's used for their SQL. But maybe it backs up also Windows servers. I'm not sure. Not entirely sure. I do know that it's for their databases at least. Which I'm not even sure if people use. What is it called? TSQL? That's theirs, I believe. All right, Microsoft cost management updates. So they also released a bunch of things. I'm going to leave a link to this in case you guys are using Azure. Oh, hey, sorry on the YouTube comments. My Twitch is ClavenX. Let me type it into YouTube for you. That's the Twitch. I do follow the Twitch chat. So sorry about that. Sorry I missed your comment. There it is. So yeah, I do follow the Twitch a little bit closer. Obviously, I do check the YouTube. For the most part, I put them to YouTube so that people who want to see them see the recorded. If you want to go back to that, you can. So yeah. TCP stream. Thank you for the follow. Appreciate it. Probably at the end of this week, I'm going to have our custom alerts done, at least working. So we'll have our custom alerts that will pop up on the screen. Although I might not do them during the news. Throughout the week, I do some programming. We just program on some stuff like that. And yeah, so I'm doing my Twitch streams are on mostly, well, right now they're on making the Twitch alerts. But after that, I'm investigating cloud technologies and building our own cloud. So you can follow my experiments there. Thanks for joining. All right. So yeah. Anyways, did I post this link? I don't think I did. Let me post this link. Oh no, I did. I already did. So you can follow this if you're looking at trying to do cost management a little bit better on Azure. They have some stuff that is coming out to help you. So yeah, give it a look. And oh no. Yeah. So we have one last cloud to cover. That we don't normally cover, but they released a bunch of stuff. I know that some of us use it, and it's kind of gaining some popularity. I actually like their take on being a cloud provider. I actually do really like their take. I disagree with some of it because it's very much built on just JavaScript and supporting just JavaScript, and I think that's a kind of a narrow view. But they did some really cool stuff in that narrow view, so I want to give them credit for that, because I think that yeah, interesting. Okay, so let's jump into it. Now, I actually had this was out of place. The use of the AI. I know that we talked earlier about the Samsung breach because of ChatGPT. I actually had another article just because I like to make sure that I follow up with plenty of articles. I'm not an investigative journalist, but I try to do my best on these things, making sure that I don't report April Fool's jokes. But that was the worst stream. All right, so Vercel, they are the creators of Next.js. They make their own cloud, very much geared towards Next.js projects, period. But today they released some storage stuff. They released 3 storage projects, or this last week, that makes it easier to do storage inside of Next. And actually, I wanna investigate these more. We're gonna talk about them in a little bit, but this is kind of what I wanted for the Null Cloud. When we're working on the Null Cloud, this is the type of stuff that I really wanted to do. I wanted to have databases and things like that that were just easy to use in a service. You didn't have to worry about setting them up or anything like that. You used them in the code, and when that code got deployed, the backend service would make sure that you had the right database that you needed. So this is literally what I've been talking about for the last 3 months of what should be done. And Vercel did it. So that's really cool. Now, it's interesting. They didn't do all of it. So their key value store, which is a Redis solution, is actually Upstashes. And their Postgres is actually powered by Neon. And their blob storage is actually powered by Cloudflare. So while they're bringing a really easy solution all in the Vercel ecosystem, which is really cool, I think you can actually get it for cheaper if you actually do the work to actually provision these databases yourself. I was looking into it for you all because that's my investigative journalism going for you. I'm not, by the way. It looks kind of expensive. So Vercel Postgres pricing. Now, a lot of your services that you deploy quickly and easily probably will only cost you $1 or $2. Let's be real. A lot of us plan for a lot more scale than we're ever going to hit. But it's 30 cents per gigabyte. But it's also 10 cents per gigabyte of data that you write. So you pay 10 cents to write it and then 30 cents to store it. And then you also pay 20 cents for transferring that gigabyte. And you could actually read that data too. So you'd probably pay more than 20 cents. Because they weren't clear on whether this was transfer in or transfer out. If it's only transfer out, that's good, but they didn't actually clarify that. I'd like to see that clarified. I didn't look through all their docs, but I did skim through usage policies and stuff and didn't see anything on that. But you're also charged for compute time and per database. You're charged $1 per database, which is a little weird. But anyways, I think this is really good. Even though it's a little expensive, you're paying the price for the ease. And if you're really starting to scale, you can transfer into something that's cheaper. But this looks super easy. Super easy. So yeah, I'm excited about that. You don't want to manage a database, you just want your code to work. So then I also looked at there was the Postgres pricing, and then I also looked at their key value pricing. Key value pricing actually looked better than I thought. A lot of times key value pricing is more expensive. They didn't state that it's all in memory, so maybe it's not all in memory. That's maybe what makes it usually a little bit more expensive. So yeah, maybe it's all actually on drive. But yeah, I was super excited. I think this is kind of what I was thinking about with the Null Cloud, some of the types of things that I would like us to be able to provide, where we do everything so that it's easy. I like it. I like it. I was really excited about it. All right. Let's continue with our cloud. We have a availability report from GitHub. They were actually down 4 times this last month. I don't know if you guys felt it. I know of two of them. Two of them, or one of them, I think happened when I wasn't using GitHub. I don't use GitHub 24/7 times, 24/7. So yeah, in April we experienced 4 incidents resulted in degraded performance across GitHub service. I like this report. I like reports where you come up and sum up your service degradations. Obviously you should have a report after each one of them, but just bringing this up and talking over the steps that you went through to make sure and reiterating that you're working on the stability of your service. So, yeah, this one was only 11 minutes. I mean, it's your code. You don't check in code every 11 minutes. So this one was probably pretty easy to miss. Yeah. So. All right. So that was it for the cloud news. Now we have I have some Kubernetes stuff to go over. Something that's come to mind. I say Kubernetes, really just one Kubernetes thing that I saw like 2 months ago. I had questions about, and I kind of pushed it aside, and now it's come up again. And so I'm gonna bring it to your guys' attention with as much as I know about it. We're going to talk a little bit about the open source world. I have one article on open source, the open source world. And then we're going to talk a little bit about machine learning, then work from home. And then we have the legendary AWS report that has shaken the entire community by saying something I'm pretty sure that I've said. Now, I haven't read the article, but the title of the article is something like scaling up the Prime Video service, reducing costs by 90%. I have said many a times that generally the cheapest way is a monolith. That you don't do microservice because it's cheaper or even faster. So now 90% seems like a staggering amount. I wouldn't have expected it to be 90%. But I would also say that stateful. So I don't know if their service was stateful. I haven't read the article, but that kind of makes sense if it's a stateful thing as well. If you're doing something that has a lot of state that gets passed around between services, if that's what you're doing, that seems like it could be pretty expensive and pretty hefty. So let's dig into the Kubernetes things. We have some exciting stuff to go over. I'm going through it kind of quickly for you all. Kubernetes GitOps adoption with KubeFirst. So this is Virtue, a company I almost never heard of before. Now, about 2 months ago, I saw that Kelsey Hightower starred KubeFirst, and that's what got me looking into it in the first place. And if you're like, what is KubeFirst? Well, it's kind of an open source Kubernetes stack. Every team that builds on Kubernetes builds this platform, and this platform has a bunch of standard stuff that most teams use. And that's what KubeFirst looks to do. It looks to build a standard platform. So this is their little advertisement, with KubeFirst, the number of people to create your platform, the amount of time to create your platform, the amount of technology you'll start with. Some might say the amount of technical debt that you've started with, depends on how you look at it. How automated the platform is when you start. So basically the idea is, now, I don't think that you should start with KubeFirst if you don't know these technologies that they're bundling in. Argo CD. I love Argo CD, but if you don't know it, this is just going to give you a whole steaming pile of stuff that you don't know. So, that being said, I think where's the Git repository? There we go. Now they make some other stuff. I want KubeFirst. Where's KubeFirst? Come on. Usually I open these ahead of time. All right. Where's the repo? Where is it? Here we go. All right. I don't. Oh, it. I think I misspelled it. Anyways, here's the repo. I'm gonna drop this in the chat for you all. So this right here is KubeFirst. Now, the interesting thing with KubeFirst is they have basically support for local, and they actually install Git inside of that. So like they build in support for GitHub or GitLab for either one. So they do local, Civo, and AWS. I imagine there'll be GCP support. I do believe that you can actually do GCP with local. Like local pretty much supports everything. It's just not fully integrated into the platform. But yeah, it gives you all of this stuff. So it gives you runners for either, GitHub or GitLab. So you want to run your actions inside of your cloud. It gives you that. It gives you Argo CD. It gives you Terraform infrastructure as code with Terraform, and gives you change management with Terraform Atlas that allows you to scale up your system in AWS. That's kind of that AWS specific that you wouldn't get if you did local with GCP. It gives you vaults with Secret, Ingress controller with Nginx, TLS certificates with the thing that manages certificates. Cert Manager. My goodness. I'm good with words. So it gives you all of that kind of in a package. So it itself is really nothing. It's nothing, but it's everything at the same time, because it's all of these little things that yeah. So it gives you all of this stuff in a platform, which is actually pretty cool. I think that this is pretty cool. Although, again, I think that this would only be useful for people who already know why these things are useful. I don't think that it would be good for you to start out and be like, oh yeah, I just want a platform, and I don't understand it. Yeah, you should probably understand it first, and then it's pretty good. So, anyways, I saw it. I thought I should give it a shout out, let you guys know that I had been watching it, and yeah, that it's there. So cool. Now on to open source news. Was there anything else in Kubernetes that you guys saw? I know that we had the KubeCon that just in Europe. I will be covering the US one better. I learned out how to get tickets early so I can get tickets for cheaper. So I'm going to be doing some, I might even do some streams on KubeCon as it's going on, but I'll cover those better in the future. But until, I think there's still like 2 weeks before those videos come out as available. So yeah, anyways, I can only do a little bit from what I see other people that actually got to attend. Something pretty big, I think, in the open source world is this right here. My first day at SUSE. It is pronounced SUSE for all of you scrubs who call it Susie or Seuss. It's SUSE, just so you know. I think this is, I don't know Dirk Peter von Leeuwen. I don't know him, but I think this was much needed for SUSE. So again, could be a horrible person, could be a saint. I don't know Dirk Peter von Leeuwen. I'm probably destroying his name, and I'm sorry, Dirk. I'm sorry. But this has been needed. Their leadership took a company that operated much like family and operated much like standard corporate business America. And I saw it lose some of its best engineers during that time. Management didn't listen about what it was going to do to their company's culture and what engineers they were going to lose over it. And because of that, Yeah, it lost a lot. So I'm really I don't again I don't know much about him, but I'm excited about this. I'm excited for SUSE. SUSE, you know, I really like. I don't use their OS at all. At all. I use Ubuntu and Arch, but I like what the company tries to do and stands for in the past. So I'm excited. I'm going to be watching this. I'm going to see how it goes through. I know some people that still work there, so I'm going to be keeping in touch with them to see how it grows. All right, that's not what I meant to do at all. Not at all. We're going to try to merge that back. Okay. Now, we talked the last 2 weeks about some AI stuff, and we're going to talk about more. 2 weeks ago, I talked about this. OpenAI closes 300 million shares, $300 million at about a $30 million or a $30 billion, a little less than $30 billion valuation. Now, I said at this time, I didn't understand the valuation because I don't understand that what they have that other people don't. Hugging Chat is a new one. The open source community is coming out with a bunch of new stuff, and this is actually really cool. It has actually two models that you can pick from. The model that's made for language and the one that's for the coding. The coding one doesn't do very well if you ask it things that aren't coding, but it's actually fairly good with coding questions, which I asked it a trick question because Rust doesn't have switch cases, and it said yet. I don't think Rust will ever. Yet kind of implies that it could, or they're planning on it, but I don't think they're ever planning on it because the match statement's there and already does that, so there's no need for that. But even with a trick question, it did fairly well and will generate code. So I stated I didn't know why people valued the company so highly because I saw that what they had wasn't that unique. it's the best out there, but it's the best by a little bit. And the things that are out there that get trained for $100 are fairly competitive. Not as good, but fairly competitive. So this last week, this article was brought to my attention. I only saw it this last week. I don't know exactly. Do they put a time when they post it? Posted on May 4th. So, okay, so it was this last week. And basically, there's a leaked document that Google says we have no moat, and neither does OpenAI. And this has pretty much been my point with these is, yeah, this guy actually reiterates, while our models still hold a slight edge in terms of quality, the gap is closing astonishing quickly. Open source models are faster, more customizable, and more private, and pound for pound more capable. What they mean by pound for pound more capable is that they are doing things with $100 and 13 billion parameters that they struggle to beat with $10 million. And when they say $10 million, they mean in the cost of training, how much they're spending to train the model, and 540 billion parameters. Oh, sorry, I need a drink. So this is where I don't understand this. I actually feel like this is going to be one of the biggest crashes out there. It's going to go from $30 billion to $1 billion. It's going to be worth very little. I don't know. I could be very wrong. Because it's going to be worth something because Microsoft is still leveraging it to do things like Copilot and things like that. So, and Microsoft Bing is still powered by it. So there is still definitely money that they're going to bring in. I just think that its moat is closing in. So this was cool. I'm glad that this was posted because I like finding people that agree with me. But we'll see. Obviously, maybe they have something else up their sleeves. The interesting thing here is that with Google releasing this, we have no moat, and neither does OpenAI. I always assumed that Google had something way more advanced in their back pocket. So we talked about the person who, thought that Google's AI was sentient and things like that. And one of the things like Russell and I talked about is, well, maybe they have something internal that is way more powerful, like way, way, way better than anything that we've seen. And I would say that this tends to disagree with that statement, which is interesting because pretty much their leader in the AI, one of their biggest AI people, just left this last week. So, yeah. What about you all? Do you think that it's overhyped? Do you think it's overhyped, the AI stuff, or do you think that? I mean, I guess there's two questions here because is it overhyped? Is the first question, where it doesn't even nearly do as much as I haven't seen it do. If you want to say that it can make your notes more concise, absolutely. If you want to say that it can help you write something and give you pointers, yes, it can. Can it do those things without your input? I haven't seen it do that yet. I haven't seen it do anything without input from a human. And however we wire it up to get input is still being driven by us, and which actually affects the AI's results. So I haven't seen it, but is it overhyped? And two, does OpenAI have the moat? Does it have the competitive advantage to be worth $30 billion? For me to see a company worth 30 billion says that you have a competitive advantage that another company can't just, another company can't just come and create in weeks or even a year, let alone weeks. So. Another thing we've talked about, or at least this is the thing that Russell brought up, which I hadn't given a whole lot of thought to, but maybe it's the end of the large corporations being able to buy stuff. It seems like VMware Broadcom tried to buy it for $61 billion, and they're still being put through, as CRN here puts, Broadcom's 61 billion VMware deal is being put through regulatory crucible. Like, it seems like we're kind of at the end of the era where these companies can buy anything more, which generally makes them the next IBMs. Like, that's what I've seen. These massive companies become the next. IBM has done this. Both all of the major tech companies should talk to them about it, where they stop spending and they try to make their investors as much money as they can, without spending money. I think that that's actually the real threat of these large companies. They lose their sight, and they put short-term gains over long-term objectives, and they eventually, slowly, maybe over 100 years, kill the company that way. And I think that they're at the verge of starting to do that with some of these. Google, AWS, Microsoft. Microsoft kind of revived I Hated Bomber, but Bomber actually did a bunch of stuff to help revive it. And I like to call him Santag, but I don't know how to pronounce the new CEO of Microsoft. I think has done a really good job. But they could start to slide back into that. To further go on that, Google employees complain about the CEO's pay raise. I call him Sundar. I don't know. He's never told me his name. If he'd like to be interviewed by me, I would happy to interview him, and he could tell me how to pronounce his name. And from now forever on, I would say it correctly, but I don't know. So he got a pay raise while they were laying people off. This is something where we had a conversation last year, or maybe earlier this year. Anyways, several months ago at least, of where if a company is going to lay off because their C-suite made a mistake, the C-suite should lose pay first. So I think that this is what eventually kills a company. Because if you reward the CEO for laying people off because you now made the investors more rich, they're going to continue doing that behavior. You're reinforcing the behavior that is nearsighted. You're going to get nearsighted gains for now. I think a lot of then we can go on about how a lot of jobs at Google people weren't doing anything. So like maybe the layoffs were really really good. I don't know. I've never been at a company where I didn't have anything to do. I've always been where I have 20 things more than I'm capable of doing. So I've never experienced this. But if that is actually the case where there was people sitting around doing absolutely nothing, then it kind of makes sense. All right. This is an article I think everybody should read. We're off of the painful topics. We're going to go into some fun topics. Building network art analytics version 2. If you're a software engineer, you want to learn. It's a high level design of a system, but it actually made me think about how I was going to, or how I would analyze network traffic, because I don't do it very often. I use people like Cloudflare to do it for me. And so it went through the thought process with V1 and why in the end it had to be rewritten because of just how the systems are created and designed. Now again, it's pretty high level. You're not seeing any code or anything here. This is like a system design. But I learned stuff from it, and I thought that it was pretty good. So if you're interested, especially if you're like me and want to create your own cloud, this type of stuff is useful. On top of that, there's the Backblaze drive stats for Q1. I always like looking over these. I'm going to leave a link with you guys if you'd like to look over them. They're just drive stats for all the different drives that they've done, how long they last by average in months, how many of the drives they had, the drive days, which is how many days they had that drive running, and how many failures that they had. Some drives they don't have nearly as many, so you only have 93 of this drive. So it's one drive failure at 4.33% probably isn't super accurate. They had one drive failure. They could have had 1,000 and still only had one drive failure. So again, this one probably doesn't mean a whole lot. But these that have over 10,000 drives with over 1 million drive days, these you can start to see like, okay, this one maybe is not that great of a drive. It has much higher drive failures than a lot of the other ones that had, over 1 million or right around 1 million drive days. Now, it's not often that we're looking at these industrial drives to run ourselves, so, it's not that useful to many people on a day-to-day, but it's still interesting from a software engineering perspective. So yeah. Google rolling out the passkeys. So they're going to be the first major platform to roll out passkeys. Passkeys is kind of the solution of the, I believe it's the FIOD. It's in here somewhere. Let's find it. It's Microsoft, Google, and Apple have launched the necessary infrastructure to support passkeys, but never used passkey in your life. You're not perfect. Oh yeah, the FIDO Alliance. I was off. Don't ask me what that stands for, but basically they're trying to make it easier for you to sign in across things. Passkeys is going to support biometrics as well as YubiKeys. So if you have your YubiKey like you should, it's going to be supported in that. So Google's the first one to release it. I'm hoping to see it in more. We'll be able to get rid of our passwords in general. Pretty good. Now, there's been a lot of stuff on remote work. I think that we're going to do the AWS one. We'll talk about this one next week, unless we have a better one. The 3 C's to building a strong remote work team. We'll instead do this one, scaling up Prime Video audio monitoring services, reducing costs by 90%. We're going to talk about this. We're going to react to it. We're going to have some fun. So other than that, the news in general is done. If you'd like to stick around and see about scaling up Prime Video audio, that's weird. It's Prime Video audio video monitoring. It just seems redundant. Anyways, we're at the end of this. If you're new here, we always cover, or not always, we just started doing it a couple weeks ago. We do one article, we read it together, we have a conversation together about our thoughts on it. Now, I've been pretty open about microservices, as microservices, in my opinion, are not a one-stop shop or solution. In general, I've said that it's actually not the most performant. The most performant would be a microservice because it's all contained into one thing. The only problem with a monolith, there's two problems. Now, some people think monoliths hold state, which I don't believe is necessarily true. You can have a monolith because you do hold state, and thus because you hold state, you are a monolith. You don't scale out because you can't have a second copy because you have that state. But that's, again, this is why software engineering is so difficult. That's a very microscopic view on a big topic. Now, I think that this article is going to be interesting because, again, obviously I'm not right about everything, but I have had my thoughts on this, and I've even released some videos on my YouTube channel about why I think people get microservices wrong. And one of them is because they think that it's a technical design decision. And while there can be some things about it, like I think event-based is awesome. But event-based doesn't mean you need microservices. You can still do event-based with a monolithic application. Did you know that? It's actually true. You can do that. It's absolutely... You can have 3 or 4 monoliths that... Just because you have a monolith doesn't mean everything is in a single monolith. It just means that you have a few large pieces of code. All right. So obviously, I'm going to lose followers for stating all of that. I do like microservices, but I do believe that microservices is a way of managing teams, not a way of managing technology. So let's read this. All right. At Prime Video, we offer thousands of live streams to our customers to ensure customers seamlessly. You know what? Just from the top of this, is this because it's dealing with state? I almost wonder if this is because it's dealing with state. But higher scale, resilience, and reduced costs. They're also saying that they achieve higher scale and resilience. The scale doesn't actually surprise me, because I think that a lot of people get into this trap of theoretically microservices could scale better. Or that you have these microservices for scale. Actually, I have failed people in architectural interviews because they say, we're doing microservices because I want it to scale. And a lot of times I'll say, well, what do you mean scale? And they'll be like, oh, I want it to scale horizontally. And I say, that's just not having state. Everything can scale horizontally if you don't have state in it. If you do have state in it, then it becomes much trickier. You could use like something like Raft or partitioning to scale horizontally, but it becomes much more difficult. Stateless makes it easy to scale horizontally, not microservices. Anyways, the move from a distributed microservice architecture to a monolith. So I'm wondering if some of this has to do with statefulness, because if you're passing states between microservices, you can actually get bottlenecks. And I'm wondering if that's something that they ran into, and that's why they could actually achieve a higher scale. I'd be interested in talking to this engineering team about it. The resilience is another really interesting thing. I generally think that the event-based systems are very resilient. And I want to know how, I hope they go into details about how they architected some of their resilience with a monolith. Now, again, monolith doesn't mean you can't have multiple copies of it running, so this could make tons of sense. And obviously, it will reduce costs. This is a no-brainer. This seemed a little high to me. I kind of wonder what their microservice architecture was to get this high of a cost reduction, but yeah, we'll see. We offer to ensure customers seamlessly receive content. Prime Video sets up a tool to monitor every stream viewed by customers. This allows us to automatically identify perceptual quality issues, for example, block corruption or audio-video sync problems, and trigger a process to fix them. Our video quality analysis team at Prime Video already owned a tool for audio-video quality inspection, but we never intended nor designed it to run at high scale, which is fine. You know what? Some people will be like, oh, why didn't you design it first to scale? See if people use your thing first, then design it to scale. Our target was to monitor thousands of concurrent streams and grow that number over time. Yep, that makes sense. While onboarding more streams to the service, we noticed that running the infrastructure at high scale was very expensive. I mean, that's generally true about high scale. I don't know what they mean by very expensive. This could be billions of dollars. This could be millions of dollars. This could be thousands of dollars. It depends on... My high scale is like hundreds of dollars. We also noticed scaling bottlenecks and prevented us from monitoring thousands of streams. Okay, so I talked about bottlenecks. That is... I think this is indicative of challenging design. I'm not going to say bad design, but it's easy to design in bottlenecks in a system like this. So we took a step back and visited the architecture from an existing service, focusing on the cost and scaling bottlenecks. The initial version of our service consisted of distributed components that were orchestrated by AWS step functions. I don't know why they would use step functions. Sorry, I'm just... They consisted of distributed components that were orchestrated by step functions. The two most expensive operations in terms of cost were the orchestration workflow, and then data passed between distributed components. So they're orchestrating something with step components, and then data is being passed. Okay, so this is what I said at the very beginning. You guys need to listen to me and learn. I said if you're trying to pass a bunch of states between microservices, that could be really expensive. Holy crap. So this is kind of what I was thinking at the start. I'm not perfect. Maybe it's a lucky guess. But this is a classic bottleneck when you have this, you make a stateless application that then depends on state, and you're trying to pass a bunch of data between the components, which another thing that you have to worry about with microservices is making sure that services are co-located beside each other. One thing that you can do here is actually put things on the same nodes. So make sure that you have the same services on the same nodes to try to alleviate some of that. Now, obviously, there's only so much you can do, but it's actually a big deal to make sure that you're not jumping regions, that you're not even jumping availability zones. Yeah. So to address this, we moved our components into a single process to keep the data transfer within the process memory. Okay? Which also simplified the orchestration logic. Because we compiled all the operations into a single process, we could rely on scalable, sales pitch instances for the deployment. Our service consists of three major components. The media converter converts input audio video streams into frames or decrypted audio buffers that are sent to detectors. Defect detectors execute algorithms that analyze frames and audio buffers in real time, looking for defects, such as video freeze, blocks, corruptions. I would actually love to know more about these. These seem like interesting problems to try to detect. especially if you're looking at frames, like a frame of a video. How do you know with a frame of a video if the video is frozen? Block corruptions may be a little bit easier, but doing that efficiently, these are some of the really fun algorithms. This is when your competitive programmer actually does well. They're like, oh yeah, we could use this algorithm too, with a sparse array, and you're like, oh, wow, a sparse array is useful. Sparse arrays are useful, I know. And send real-time notifications whenever a defect is found. For more information on this, okay, well, oh, they use machine learning, so they don't know the math. Okay, interesting. I think this is a good way of doing it. The third component provides orchestration that controls the flow of the service. We designed our initial solution as a distributed system using serverless components, for example, the AWS step functions or AWS Lambda, which was a good choice for building a service quickly. I disagree. I think it's a horrible choice for building something quickly. In theory, this would allow us to scale each service component independently. However, the way we use some components causes it to hit a hard limit of scaling around 5% of the expected load. Holy crap, that's bad. That's pretty bad. All right. Also, the overall cost of the building blocks was too high to accept the solution at large scale. All right, let's look at this and try to understand it. So we have our audio video stream here. The media conversion service, I'm guessing this is the thing that like transcodes it. Audio video buffers, so they're storing their videos in S3, and we're streaming it here. And your entry point was an AWS Lambda entry point, parallel execution. I'm not sure I'm understanding their step functions here. I'm not sure I'm understanding why these were in the service at all. And this might make tons of sense. Let me think through it. Like, so maybe what it's doing is when you start, like, I start streaming. I'm just spitballing here. When I start streaming, it would spin up a instance, a compute unit, a pod, a container, a EC2 instance to handle the stream just for me. Is that what they're doing? I don't know. So, okay, overall cost of the building. So here we have the entry point. It starts the conversion. So basically, I guess this is linking you up with a media conversion service, which was outside of what they changed. I guess it's this thing in here that they changed, which again, I would say that even here, you can see that they went from a monolith. They went to multiple monoliths. The media conversion service is still outside. This is where I'm saying a monolith doesn't mean all your code lives in one code base. It means that you don't break it up per team. So I think this makes sense. Okay, let's keep going. The main scaling bottleneck in the architecture was the orchestration management that was implemented using AWS step functions. Our service performed multiple steps transitions for every second of a stream, so we quickly reached account limits. Besides that, AWS step functions charges users per This right here, to me, actually sounds like using a tool that wasn't designed to do what they were trying to do. Our servers perform multiple state transitions for every second of the stream. Wow. AWS step functions charges per state transition. Wow. Like, this just sounds like they didn't understand the service that they were using. All right, let's keep going. The second cost problem we discovered was about the way that we were passing video frames around different components. To reduce complexity, expensive video conversion jobs, we built a microservice that splits videos into frames and temporarily uploads images to an Amazon S3 bucket, detects defect detectors, where each of them also runs on a separate microservice, then downloads images and processes it concurrently using AWS Lambda. However, the high number of tier 1 calls to the S3 bucket was expensive. So basically, these things we're pulling a bunch from here really quickly. And so my guess is what they're saying is if you combine these two things here and just pass the frame directly to them, they don't have the expensive story. And I say these two, there might have been 3 or 4 things going on here. Okay? Then download images and process it concurrently using AWS. However, the number... Okay, yeah. From distributed microservices to a monolithic application. To address the bottlenecks, we initially considered fixing problems separately to reduce cost and increase scaling capabilities. We experimented and took a bold decision. We decided to re-architect our infrastructure. I mean, that doesn't sound bold. That sounds needed. Honestly, there's definitely things that they could have performed better here, like using fewer step functions. But in the end, they were always going to hit these hard limits of step functions. They could have gone to other teams and said, hey, fix the step functions. But that might have been per design. By design, they work that way. We realized that distributed approach wasn't bringing a lot of benefit in our specific use case. So we packed all of the components into a single process. The other thing that I see here is this sounds like a single team. This seems like a single team, which I'll reiterate that a single team shouldn't have multiple microservices. That's not the point of a microservice. The point of a microservice is for there to be separate teams. This seemed like a single team. This eliminated the need for the S3 bucket as the intermediate storage for video frames because our data transfer now happened in memory. We also implemented orchestration that controls components with a single instance. This sounds really good, and for multiple reasons. This actually saves memory if you think about it, because each of these step function detectors would have required to load the frame or the buffer in memory in the first place. So you're duplicating the different places that this is in. This is a classic a classic issue with microservices that can happen, but usually it's separate teams. If this is all the same team, this was not understanding what microservices solves. The following diagram shows the architecture of the new system after migrating to a monolith. Detection is a monolith, and yeah, so, and this is what people don't realize, that you can have a monolith and still have separate things. Just because they have a monolith doesn't mean that they got rid of this result aggregation, doesn't mean that they got rid of media converter, doesn't mean that they got rid of having different things. I bet you this was a different team. I bet you this was a different team. There's still Amazon SNS for real-time notifications. There's still their other things. So this to me makes a ton of sense. And really, I don't even think that this is a monolith, really. Honestly. Honestly, this doesn't even feel like a monolith to me. I could be wrong. It's not what a lot of people think of a monolith, I think. Conceptually, the high-level architecture remains the same. We still have exactly the same components as we had in our initial design. Detectors allow us to reuse a lot of code and quickly migrate to a new architecture. I think this makes a lot of sense. In the initial design, we could scale several detectors horizontally, as each of them ran as a separate microservice. So adding a new detector would require... So this is the one downfall. If you have one detector that requires scaling, you have to scale all of them now. In this thing, instead of having each detector separate, you have them all together. And so to scale them, you make a copy of the whole thing and run 2 of the entire detection service. But you can mitigate that anyways, because if detector 2 isn't being leveraged that much, well, you can make it so that in the monolith, it can prioritize detector 1 or spin up more threads for detector 1 in the service. So you can mitigate that problem with monoliths really easy. What I'm saying is not hard things to do. It's pretty easy. We could say horizontally as each of them ran as a separate microservice. So adding a new detector would require creating a new microservice and plug it into the orchestration. However, in our new approach, the number of detectors only scales vertically because they all run within the same instance. Our team regularly adds more detectors to the service, and we already exceed the capacity of a single instance. To overcome this problem, we cloned the service multiple times. What did I say? Being able to run as a to scale horizontally isn't about, it's about not holding state. It's not about being, so microservice is about doing one thing and doing it well. I would even say that you could argue that this is doing one thing and doing it well. It's detection. It's probably not the strictest sense of a microservice though. So yeah. Our team regularly to overcome this problem, we clone the service multiple times, prioritizing each copy with a different subset of detectors. Like I said, you can make it so that, what they're saying is like, this service runs these first 3, this one runs 4 others. Okay, sure, whatever. That's a little bit of a different way of they're almost sharding the service, so they just decide to shard instead of having like some sort of dynamic allocation on how many threads get assigned to a different a set of detectors. But that's also fine. We also implemented a lightweight orchestration layer to distribute customers' requests. The following diagram shows our solution for deploying detectors when the capacity of a single instance is exceeded. Right. Yeah. Simple. Keep it simple. Everything should be simple. This is good. Microservice and serverless components are tools that do work at high scale, but whether to use them or over a monolith has to be made on a case-by-case basis. Moving our service to a monolith reduced our infrastructure cost by 90% and also increased our scaling capacity. Honestly, maybe I'm wrong here, but this doesn't seem monolith versus microservice to me. Am I wrong here? This doesn't feel like monolith versus microservice to me. This feels like, I don't know how to say this in a good or not, but like, this is understanding the tools and how to use them. This is something I repeatedly say over and over and over again. And you don't, if you pick a bad tool to do a job, this is not what step functions were designed for. Obviously, this is not what step functions are designed for. And so don't do this with step functions. And this is why I so rarely say don't do this only, is because I fear people latch onto those things. It's like why they think, oh, monoliths versus microservices, don't do X, Y, or Z. And the thing is, a lot of these things can be argued as good in certain scenarios. And that's why it's so important to understand what your scenario is and understand how it could be. This is why at the very beginning here, I even said that, if you're passing a bunch of state, and then we found out they were passing a bunch of state. They were passing a bunch of state here into the S3 bucket, into a bunch of different detectors, and yeah, running it that way. I gotta think on this a little more. I gotta think on this because I'm not sure that I agree with the assumption that this is monolith versus microservice. I actually don't think that was the root of the problem. By their own write up. I need to stop disagreeing with the people. I feel like every single time I get into this, I actually disagree with the results of the people's own write up. Maybe I need to stop doing that. I think this is good. I think people should be reading this. I take away a little bit different. What about you guys? What are you guys thinking? Write something. Tell me something you're thinking. Hmm. All right. Well, I see you. 3 people. The silent type. Just want to watch? Don't want to tell me your thoughts? Don't want to speak out about the great microservice architectures that we do? That's fine. That's fine. Don't worry, I will make fun of you eventually. I think I was just making fun of you. Anyways, thanks for watching. If you guys want to talk about this on Discord a little bit more, we do talk about these topics. We do have our own arguments about them. I think I need to think about this a little bit more. Maybe we'll talk about it again. Maybe I'll do a stream about it. These topics are really interesting to me because I'm looking at building my own cloud for you all that makes it easy to do these types of things the right way. I want something where it's like you don't have to think about all this stuff. You want to write your application, and running it properly, running it the right way just kind of happens, where you don't have to worry about the orchestration layer and whether you orchestrate these with step functions or Kubernetes or whatnot. I want you to not have to think about these. So I love these topics. If you guys find other topics like this, I want you to send them my way so that we can read them, we can react to them, we can think about them, we can argue about them, and we can come out to the better solution. So anyhow, thank you all for joining. I hope that you have a fantastic week. I hope that you go out there, you create something fantastic. And I will see you Tuesday.